Alright. Hello. Hello. Can you guys hear me? Hello. Yeah, I've been sitting over there like the whole day. I couldn't hear anyone. Yeah, like, right? Like, was every microphone? Like, did no one use a microphone? I don't know. I saw one guy, the like Yelp guy was using it, but I don't think it was on. Holy moly.
Bring the people in.
Bring the people in, all right. I saw people leaving. That's like the worst feeling ever. It's like they know I'm coming up and they leave. There's not much I could do.
It's on Saturday.
Yeah, it's Saturday. I was gonna try to come in late today, but the one talk I wanted to see was at 9 a.m. The most relevant to what I'm working on right now, anyway. Bring the people in. What's up, man? I got this thing working. If you guys want to follow along, we're going to operate out of one notebook today, and the goal is to never leave the notebook. And we're going to be interacting with Kubernetes, let's see, Amazon, Airflow, Google Cloud, of course Docker. So it's kind of fun not leaving the notebook. It's challenging, but GitHub.
Go for it.
Should we start? Okay. Thank you, by the way. I've worked so hard to get into this particular conference. I came, I don't know, a year and a half ago for one of the early ones, and sat in the back, like a little kid waiting for something. So I'm very happy to be here. So, but yeah, if you guys want to follow along, go to Flux Capacitor Pipeline. You can look for this notebook. Like, you know how these notebooks render pretty well in GitHub. If you know that trick, if you're in the know, I'll show you guys. You can click the code tab, hit T from anywhere within GitHub. From within the code tab, and type startup ML. It's a much better search than if you actually search through the search thing up here. So you can click on that and you can follow along. It's a pretty beefy, it's about 2,000 lines it looks like. I didn't realize that. I started it right when I got in this morning. And I mean, all the demos were pretty much ready. But okay, so we're going to operate. I'm going to operate out of the live one. Please don't go on this server. Please, please, please. It's open. So don't like reverse engineer, or copy and paste that. Oops. It always does that. Like, someone has done something in the background you want to overwrite, and I'm like, oh man, which one do I want to overwrite? I don't know. Okay, so I think we all know. Is today the 20th or 20? Oh, it's the 21st. Oh man, I've been putting 20 everywhere. Okay. My name is Chris Fregly. Let's see. What am I talking about today? Yeah, I think I'm self-famous in my head for this emoji thing that someone gave me. It's a laptop tattoo one of my groupies from my Meetup gave me. I have 499 more than this one, so they're sitting over there if you guys want one. I've had people in other countries that actually occupy the apple, the sacred symbol, and so that made me feel really good. Currently research scientist, PipelineIO. This is my own company. Before that, and actually I just signed a contract actually this week with the O'Reilly folks. That's another conference I've been for 5 years trying to get into, so hopefully that'll get me in there. high performance TensorFlow in production, which is why the 9 a.m. talk was super relevant to me, right? Like just like you guys, I am chasing down what's going on with TensorFlow and how to optimize it, and going through source code and some of those tools that like he talked about this morning. I didn't know about because I'm still on I'm still trying to figure out version 12, right, of TensorFlow, and it's not even in version 12. Some of the stuff he was talking about, so it's on master. But by the time this video series and the training come out, hopefully I will be close to where that guy is. Yeah, so I've got this meetup. Did anyone come to the meetup this week, Thursday? Those people probably all left. Well, yeah, you spoke at the meetup. I did a similar talk, except all the demos were broken, and right now they're working, so I want to get through this as fast as possible. Sign up for this meetup. We hit 5,000 people at the end of the year, at the end of 2016, so we actually have a lot of good speakers coming and like a lot of traction. This flux capacitor repo, the one I showed, we hit 1,000 stars. That's this one. I think we're up to 1,200, or wait a minute. Nope, yeah, I guess 1,100. Okay. Anyway, all of the stuff I'm going to show also, this is available on Docker Hub. If you click on the wiki over here on the same repo, you'll see this sidebar that has, so you can actually recreate this entire thing. There's nothing proprietary about what I'm talking about. That was one of the things that I promised these guys when I was coming to speak. And the reality is I have nothing proprietary to even offer. So everything because I don't make any, shut off. I don't make any, I'm good at spending money, I'm not good at making money. A couple things to highlight. So someone asked me right before they were leaving if they could reproduce what I'm doing today. There's a local version right here. Yes, everything is based on Kubernetes that I'm going to show you. This is actually using Minikube, which is pretty close. It's pretty up to date. They're sort of downstream from the main Kubernetes project, so sometimes they don't have a lot of features. But for the most part, for the Docker container orchestration, for the simple stuff, like adding containers, like removing containers, all that stuff is there. This is how to get it working on GCP. This is how to get it working on Amazon. This is kind of the overall architecture here. We're going to cover this here, so but that's what's going on there. I've got a surprise for you guys today. I'm actually going to deploy both to Amazon and to Google. So we're going to do a hybrid deployment. We're also going to run some sweet load tests, and I've been having mixed results. For the longest time, Google was outperforming Amazon for the same dollar amount, for the same instance type. It was blowing it away. It was like double the performance. This is on the prediction side. That's the focus of this talk, is sort of the inference. And then using my experience at Netflix with Netflix open source, taking TensorFlow models, putting them in there, taking Spark models, deploying them with PMML, and then load testing everything. So Google was outperforming. And just the other day, all of a sudden, it was equal, and then just last night, Amazon was actually double. So I don't know if they caught wind and they kind of snuck in, they turned the turbo button on, like they're actually paying attention to me, right? So it's been kind of all over the place. So we'll run it today and we'll see what happens. I thought for a while it was probably that, so I used the R3 2XLs for the prediction side of things, 60 gig instance, 8 cores, and then on the Google side I used the N1 high mem 8s, which is similar, 8 core, 52 gig. They're roughly the same cost. And I thought possibly I was getting on certain instances that had shared tenants and things like that, switched over to the dedicated servers, but was still seeing the same crappy performance from Amazon. But again, now I'm not quite sure what's going on. So maybe I ended up getting a crappy, because I've been using Google's container engine, but selecting the N1 high mem type. So don't really have too much insight into what Google's container engine is doing. But anyway, so yeah, everything's there. All the slideshow stuff, YouTube videos from all the past meetups and fun talks. Netflix, Databricks, IBM, Spark Tech Center. This logo is completely in violation of every single Apache, call it whatever. But I continue to use it because it's hilarious. because when like IBM partnered with Databricks, they didn't even know about this whole Apache because they didn't really understand Apache. But it's been out there, and I'm I think the only person that uses it. And yeah, like sometimes I get an email from those guys, but if you just ignore them, or send back a fake like bounced email, then they tend to leave you alone, the Apache guys. All right, so everything we're going to use. One thing I do want to highlight, actually, this link goes directly to here. I've got this pretty, so if you guys went to the AWS AI day the other day, which I did not, but I've seen some of those talks before. They have their own Docker, or their own, like AMI that has, TensorFlow and MXNet and things like that. So I've gone one step further, and I've got a Docker file, actually Docker image, that has all the same things. One thing that's cool, so you can deploy it either on Amazon. Well, I guess for the GPUs you can't use Google, but and so yeah, I actually just updated it for the P2 series here. So let's see if let me show you guys what's going on. So yeah, here's just some steps to get it going. It's using, you need at least Docker v112. If you follow these steps, this is going to set up all the NVIDIA crap that's on, that you need. Then it uses the NVIDIA Docker. And this is, so I'm not going to spend too much time on this, right, because you can link to it, but this is the G series with one of the K520s. This is the better G series, so these are the older ones. These are the ones I think the, what's his name, was it Jeremy, guy, the second speaker was talking about. And then, is he still here? Yeah, no. The new P2 series are actually pretty badass. We got the K80s, so here's one. So here's a 16, it's a snapshot. This is actually me running this particular Docker image on this instance, and I was doing some training, and to take this snapshot, by the way, cost me $2,500 because I left it run for a couple weeks and just totally forgot about it. I ran it in like a different region, and the only way I was notified was when Amazon sent me the bill. So, and then I very quickly turned it off. But what I wanted to show is that you can, so this is single GPU. There's kind of a picture of multi-GPU training. It's just doing the CFAR thingy. 2, 4, 16. You can see, I didn't, people keep asking if it's going up linearly. You can kind of see, I don't have it charted nicely, but if you look at the numbers, the throughput, so one GPU, 700 examples per second is what I was getting. Oh yeah, one thing about GPU stuff, which I guess I had known at some point, but didn't realize when I was doing my benchmarking, was that each GPU has to get warmed up, right? Or else all of your benchmarks are just like a joke. So, when I would go from 1 to 2 to 4, and then when I went to 16, I was seeing crazy, crazy stuff happening. So, not unless all 16 have actually been warmed up and things, I can't remember the term. Oh, it's this PTX assembly compilation, right? Like that's what's going on there. So, yeah. So just make sure in the future, and there's a link to actually what's going on. I think this is our buddy Yaroslav he was one of the original TensorFlow guys, I think, right? He was answering, he's all over Stack Overflow with TensorFlow, and was explaining some of the slowness people were seeing with GPUs, and this isn't good that this network is this slow. That might bite me in a minute. Okay, so 700, and then we go to 2, and we get about double. And then we go to 4, and we don't get it double. And then we go to 16, and we really don't get double. So just keep an eye on that. I thought at some point maybe I wasn't utilizing all of the GPUs, or it was pinned to just a couple. But yes, everything I saw, they were all being used. It just wasn't going up. It wasn't 16 times. So there's some things to look into. But this is pretty cool. This is TensorBoard, as you guys are probably familiar with. The 6006, right? Like, do you know what that is? It's Goog, right? Like upside down, if you have the calculator. Not boob, Goog, Goog. So port 6006, when you see that, TensorBoard's running somewhere. Someone's left it open, the port's open. So I didn't capture, for $2,500, I didn't capture the best shot possible, but I did capture this. showing. So these, like, you could actually click on here and see for like learning rate, watch, right, like all 5 of those, and sort of see how the right, like training is like progressing. So because each run I did, I put into a separate subfolder, and I pointed TensorBoard to the parent folder, and it just knows that they're separate runs, they need separate colors. Yeah, TensorBoard's pretty good. I'm starting to warm up to it. This Docker image also has Jupyter and some examples here and things like that. All right, so let's get back to here. Kubernetes. I'm going to take for granted that you guys kind of understand what's going on. We're not using Kubernetes for anything low level like within Spark. In fact, that was one of the talks from Thursday's Meetup, if you guys want to look it up. There's a guy from Google talking about, similar to how Mesos is a like scheduler for CPUs and RAM and things like that. They're now working on Kubernetes being, in fact, someone left Mesosphere to go work on this with the Google guys, right, like to try to make Kubernetes the same type of thing. What we're talking about here is Kubernetes as basically a Docker container orchestrator, right, like placing Docker containers on physical, right, like instances, EC2 instances, or the GCE instances, whatever they are. So here's a pretty cool tool, WeaveScope. This actually, it's sort of like AppDynamics, installs on each physical node in your Kubernetes cluster and sees all the traffic going between pods, right? So pods, right? So you'll see, for example, Jupyter Hub is talking to Spark here, and I got some TensorFlow stuff. I got Elasticsearch, Kibana talking to each other. Zookeeper is talking to Kafka. You can kind of get the intuition there. What you'll see here too is, and I'm going to talk about this in a sec, there's one cluster here that is dedicated to training. It's sort of like the admin cluster, you would call it. This is where Presto runs. This is where, right, like Jupyter runs, Redis, things like that. And then there's no connections here. This is a separate cluster. And this is more for, actually, is this right? Yeah. That's not the right example, but there's going to be 2 separate clusters that we talk about. There's going to be the admin cluster, which is where we're going to train the models, and then there's going to be the prediction cluster. And I wanted to keep those separate, right, so that Spark isn't, right, like affecting the actual prediction benchmarks and things like that. So just costs a little more money for the demos, but it's definitely worth the isolation. We're going to be using Jupyter for everything. I switched to Jupyter probably early last year for this exact reason here, where I can, I can render the actual notebook. So, right, like trying to share my Zeppelin notebooks with people, for like workshops and things like that, was a total disaster. There's just a bunch of, JSON and things like that. But here I can actually share with you guys Jupyter notebooks. And I'm sort of spending time on this because there's so much to share with you guys. I want you guys to have stuff to kind of go away with, but if we don't get to everything. So here's some, so these render really nicely versus the Zeppelin notebooks that don't render nice at all. You have to parse JSON on your own. We're going to use Airflow. So in thinking about this and talking with a few customers, what we realized is that instead of using Jenkins and pulling in that huge beast, right, which is a well-known beast and a familiar beast, and has the nice DSL. It's just yet like another language, right, that like data scientists would have to think of if we're trying to give data scientists the ability to deploy things on their own, right, which is the other theme for this talk, which is, so from Jupyter, like we're actually going to build models and then deploy them and have no ops people involved, nothing. It's kind of crazy. This was a mentality I picked up at Netflix, where you sort of didn't have an ops team, didn't have a DevOps team, right? Like we were developers, we wanted to push out code. These are data scientists, they want to push out models. Why do we need someone in the middle to, do stuff, right? It just doesn't make any sense. So I wanted to stick with Python because that's familiar to data scientists. And yes, Airflow is, if you think of Airflow like code deploy, just think of it like a model deployment. What we're going to do is actually commit a model, right? Like we'll train a TensorFlow model, we'll commit it to GitHub. That's going to trigger through the GitHub webhooks and all that stuff this particular Airflow workflow. which is going to pull down that version, right, that we just committed. It's going to build the Docker image. It's going to deploy the Docker image, and it's going to right now it's going to just replace the existing model, right, with no downtime. What we would typically want to do is have a canary, right? So there's the existing model servers. There's 1,000 model servers. We would want this particular flow to push out a canary, and then right, like return back some sort of like dashboards back to the data scientist to show this person, here's the canary, here's the predictive like performance like characteristics of this particular like canary, and then here's the existing cluster of the 1,000, and see if things are different, see if it's using more heap, see if because the canary is way deeper, right, than the existing one, maybe right, like the inference times have gone way, the like latencies have gone way up, so maybe we have to do some post-processing optimizations. So let's see, Docker Hub, continuous deployment. We're going to use some of the Netflix tools here for actually showing some of these dashboards. I think I hit something here. Jumped ahead. Okay. Yeah, here's the separate training cluster from prediction cluster. I keep double clicking and it's like jumping all over. All right. I've coined this new like acronym, extreme high availability. This is across clouds. I'm hoping it catches on. XHA, like extreme programming. And of course, we're going to use Spark. We're going to use TensorFlow. Touched on TensorFlow serving this morning. Here's kind of a back if you guys remember like UML. Sometimes I just sit and dream about UML and how beautiful like my life was, and was it rational rows or whatever, where you could like generate code and the code was shitty, but it was so nice that you could generate code from a diagram. So what we're going to be looking at specifically are these servables, right? So TensorFlow serving, and in particular, there's a code servable. Let's see, inference servable. There's this concept of a generic hash map servable. So now this is kind of interesting, and actually I have a link to the code here in a sec, where you can just deploy, right, like key value pairs. So this would be like Netflix deploying out to their huge Redis cluster, huge Cassandra cluster, the person's user ID and the top 100 items. Right, this is the most basic, right, like type of recommendation. There's no forward prop going on. It's just key value pairs. So it was interesting to me anyway that actually made it out in like the open source version. And then there's these like these model deployers. The most basic one is a file deployer. Some of our like aspirations would be like a Redis deployer. You throw things onto Redis, and so this is the thing that actually takes these servables and or it's the thing that's scanning for new versions basically of the models, right? Let's see, and there's of course version policies, things like that. Let's see, let's kind of okay. So just real quick on ways to deploy things. I just mentioned KeyValue. That's the most basic. Like Netflix, for example, they have this open source project called Dynamite. That's actually an implementation of the Dynamo paper. So think Cassandra, think right, like DynamoDB, things like that, but with Redis and with Memcache, right, that can plug in. So this is super powerful. This is and it gives you all the CAP theorem, right? So it gives you consistency, the availability, the right, like network partitioning, the same semantics that you would have from Cassandra, right? Like Netflix loves, right, like Cassandra, but it was too slow for these simple lookups, right? All they want to do is when that user logs in, is to just find that person and then show the recommendations. Now that got really expensive, right? And that's pretty really rare to hear Netflix talk about something being super expensive, because they're the guys that spin up a new cluster, right, of full like EC2 instances per job, per Spark job. They actually spin up a whole cluster and then tear the whole thing down, right? Because they don't want to deal with like multi-tenancy and trying to debug and right, like go through and figure out that next morning why did the job not run. They just throw money at it. They spin up a whole new cluster. So here things were starting to get a little bit expensive with right, like so to store all of the recommendations and all the different facets of these recommendations, it was just taking up a lot of memory. So they're actually in the process of switching to this hybrid, or I think it's, so their version right now uses memcache, but they also support full Redis. But they're switching over to this hybrid memcache with Dynamite and RocksDB. So sort of the colder people, right, like people like me that I've been paying for this account, for years, I just never use it. I'll be in like RocksDB, but people who are super active will be in like memcache. So here's the specific code here for the hash, for the key value. Yeah, so they call it hash map here. So this is a like type observable. It's not like there's no like neural network stuff going on. So that's one way to deploy, right? That's just simple recommendations. Who here hates PMML? Who it's like a nails on a chalkboard, right? Like, do you hate it back there? Yeah, you hate PMML. Yeah, I could tell you do back. Yeah, pretty much. I've come to realize everyone in the world, right? Like not just the Bay Area, in the world hates PMML. People who actually work on PMML hate PMML. So I don't hate it. Like I actually think it's useful. I've used it on gigs at Apple, Cisco. I didn't work with Airbnb, but they have a pretty famous blog post that's linked here. This company, HomeAway, I have worked with. They're just like Airbnb. They saw the Airbnb blog post and decided to use PMML. The problem that they're trying to solve is they have a Spark model. There's this project JPMML. Do I have a link to it? That can take all of your Spark models, even Spark 2.0, Spark 2.1 models, and convert them to PMML. And then on the other side, there's like the evaluation side of it, the scoring or the predicting side of it, where you can take that same PMML, you can deploy it, and you can pass in the inputs, and it will provide that prediction. And this is all without writing your own PMML, which is what everyone ends up doing. And it's in JSON, and then they have to maintain it. So I think I have a note here. Please don't rebuild PMML. Just accept it. Just please try to use it, because all you're doing is just creating more technical debt. All right. So hopefully I've convinced you guys to use PMML, because that's the demo I'm going to show today. And then native code. So this is interesting. This is what I see people doing most often is they build a scikit-learn model. And they don't understand, why I'm focused on the serving layer, because they have, this like Python Flask server that craps out a lot, but they just restart it and everything's fine. And they just tell the client devices that are talking to it to just build in a lot of failure handling and just stop serving recommendations when this Flask service goes down. And people are happy with this. People are totally fine with this. Ops guys don't care, right? Because it's not affecting their job. They just have to run supervised D or whatever and restart it. So this to me is just mortifying coming from Netflix, where recommendations were how we can not have to buy the good movies and you guys would still pay money, because we could serve up recommendations. We can basically tell you what you want to watch without you guys knowing it, right? So so people do this. They pickle these things. I mean, people are doing this with Theano models right now. They're pushing it out. They have no insight into the performance. They have no metrics. They don't know anything about they just go to it every now and then, and if it's working, then they're happy. And then so the other part of this could be generating Java code or C code from the PMML. So I don't have a demo for that. I'm actually working pretty closely with the guy who built the JPMML. He's out of Estonia. He's the guy that worked with Airbnb. It's pretty much him behind this project. He dropped out of his PhD and realized he was sitting on something good, and he has I guess a pretty inexpensive place in Estonia. Yeah, I was just there. It's not like San Francisco at all. But he's got full support for scikit-learn. So he can generate PMML from. So this is the magic one right here, this evaluator. So this guy in the upper left. That's the guy that can take, so it can take all PMML, that's generated anywhere, from scikit-learn, from R, from Spark. He just had XGBoost. And he can now, score with the same PMML. So that's the part that I like, is that it's portable. So I'm like working pretty closely with him to take the PMML. Yeah, so he has this working right now where, right, like PMML, when it gets generated, is super dumb, right? And it's, the nodes are all over the place, there's things duplicated. So he's able to actually optimize the PMML. So that's step one. Step two is take the PMML and then generate Java code. Because now we can do JITting and things like that. Because right now, this evaluator runs in an evaluation or in like an interpreted mode, right? It's like always going through that same PMML as new inputs come in. So if we could like take that like newly optimized PMML and then generate Java code, generate C code, generate like GPU kernels, whatever like needs to happen, that's kind of the next step. So that's what we're going to be working on for Q1 for this non-money making company that I run, for this cash, what's the term? Cash something. Sync, did you say? Yeah. Or, yeah. Not cash cow, that's for sure. Yes, you can thank Netflix that like gives me the comfort. Yeah, right, like my Netflix options, right, like give me the comfort to do this, to spend money on. I'm like pouring it back into the Bay Area, right? Okay, so this is something cool too. This is actually a big focus for the like video series, and the first guy from Google, yeah, he actually touched on some of this. He didn't mention freeze graph, but this is one I've been working with where when you build a TensorFlow model right now, you end up with this graph, right, that's basically static. And then there's these like checkpoint files that has the actual, right, like learned values, the learned weights, the learned parameters, whatever you want to call them. If you do freeze graph, it's going to actually take the like variable nodes that are in that static graph and bring in the latest constants. So now there's just one deployable bundle, right? So this is a script. Actually, this is a really cool directory that not many people look at. It's this tools directory within TensorFlow. And there's a ton of stuff in here. You can actually crack open these, right, like mysterious checkpoint files. Here's the start of, this is kind of a hacked together script where you take the model, it's going to do the freezing if it has not yet been freezed. It's going to try to pull out some nodes that are not needed during inference, right? So like training specific nodes, right? Like things like dropout, right? Like should come to mind, right? Like you don't need dropout during inference, so pull those out. Things like summary writers, right? So where TensorBoard gets its data to render comes from a node in your graph at training time that says take whatever values I have right now and then write them out. So right, like those aren't needed during inference, right? Like you don't want to start writing things out. So yeah, this actually, so this script kind of sort of like touches on it a little bit. I think this might also, does this one do the 8-bit? Yeah, let me get to that side. So there's other techniques as well. I think I have, yeah, it's coming up here. Okay, so let's move on. Model deployments and rollbacks. So again, when you give developers or data scientists the freedom, right, like to do things, what you're doing also is giving them responsibility, right? This is like the big Netflix culture slide deck, is that you have freedom, but you also have responsibility. And you can only get that by having good tooling. So at like Netflix, for example, we, the developer, could actually push out code and roll it back. And we can have two clusters running. We could have a new cluster, the old cluster, right? Like they didn't care about cost, so we could have, right, like 2,500 instances for that old one that we'd keep around for 24 hours. We would have the new one running, so there would be 5,000 servers running, all so that we didn't have a single like second of downtime. So, but right, like the ability to have both those up and then be able to roll back quickly, just to flip a load balancer, right? That's super powerful. So that's kind of where I'm going with this whole, right? So like when you think about deploying something, you should always be thinking about the ability to roll back. Now there's a couple, I'm going to do two styles of like model deployment today. I'm going to do mutable, which is you have your 2,500 servers running and you want to push out a new PMML or a new TensorFlow model. What you do is you would just flip it in memory on all 2,500 of those instances, right? And so that should scare you guys, because what if some of them don't get it, right? And so we started to do some of this at Netflix, kind of when they were starting off going to the cloud, from data center, from Oracle, and it was a total disaster because we didn't know, and so there was all this tooling, right, that we started building, like did it get the new model? And so it was that server's responsibility that we think might, right, like have an issue to tell us if it got it or not, which was just like the wrong model. So like this whole thing about mutability, right, like being scary, yeah, so this extends also to deployments. So what you want to try to strive for is like the immutable model. So think of each time that you build a new model, you actually you build a new Docker image. And so there's no going back from that point. There's like nothing changing in memory. And then you would deploy it alongside, just like I said, you could deploy the canary and see how it goes, or you can deploy a full cluster, have them both running, right, like have the load balancer kind of spray between both, make sure everything's cool. And then if you have to roll back, you roll back. But there's always traceability. Right? Yeah, so you know that when that like Docker container is out there, that it's running this model, this right, like tag of code and everything. One thing to mention here is I'm going to be doing a demo where we use GitHub. So I'm going to commit the model. Don't ever rely on GitHub, right, like being available. Right? So this is something also that we didn't even really take a chance at Netflix. Yes, they run their own. It's called Stash or something. It's right like their own like GitHub server. They have so many processes that are being triggered off of GitHub, right, like commits and things like that. That if like GitHub is down, you basically have lost all ability to redeploy or roll back or do whatever. So yeah, so just be careful of that. Real quick, here's a couple scripts here. Here's the optimized graph for inference in that same directory. Pete Warden, so this script has essentially become, this blog mentions this tool right here. This is essentially what I'm going to spend the next month studying, is this graph transform tool. So this is all kinds of optimizations. Pete Warden, his company was acquired by Google. He is really good at like mobile deployments, and especially AI on mobile, which has a lot of it's not the luxury of like having lots of memory and lots of CPU and lots of GPU and things like that. So there's like this other trick. It's called 8-bit quantization, where you would train at like full precision, right, like 32-bit float, and then when you actually so now it's trained, but now when you go to deploy it, you would drop it down. You would kind of round up or just like lob it off, whatever, right? Like convert those floats into 8-bit ints. And because AI and ML is all kind of fuzzy and everyone, it's all black magic anyway, this surprisingly works pretty well. The sort of early versions, I did some testing. Yes, I'm sure Fabrizio probably did some testing, right? Yeah, with this stuff. Did you find it actually helped?
Well, on mobile, it runs much faster.
Yeah, does it run faster? Because the model I know went down, went down by a third or something. But yes, I didn't see much improvement. Oh, but see, I wasn't running on mobile either. Yeah, I was running on. I just like ran it again on the. Yeah. Okay. All right. So there's lots of things inside of this graph transform tool. Because I do quite a bit with Spark and TensorFlow, I find a lot of these things very similar. Yeah, I'm sure you guys do too. These are all classic database optimizations like constant folding and folding batch norms, things like that. The goal here, of course, is to shrink the file size for mobile, also to simplify the graph, right? So when I said before, if you accidentally deploy a graph that has tons and tons of extra training nodes, like you have a bunch of debug nodes and writer nodes and things like that, you'll see that, right? Like when you push out the canary, because that's going to be running alongside the current version that has been optimized or didn't have that extra debugging, and you'll see the inference, right? Like latency times go way up. So you'd want to pull it down, right? Like roll it back, figure out what's going on. But yeah, simply just like removing nodes. Also, when you're training, you want to be aware of which like specific devices, like GPU devices, things like that. But on like the inference side, when you're on a mobile phone, like you don't necessarily have these things. So you would pull out the specific operations that force you to be assigned to certain devices. Yeah. Let's see. So I'm going to admit I literally stole some of these bullet points from this morning's talk because they're totally relevant. This is the stuff I was saying. Yes, I knew about the XLA stuff. TF compile I didn't know about, and I went to look at it, and it's only a master. So yeah, that's one of those. But yeah, the term is still. I'm just gonna be blatant. I stole that from him. That's awesome. And yeah, I'll send I don't know, like some flowers or something maybe. Okay, it's the most ridiculous thing. The other thing you can do, so besides optimizing the actual graph itself, is you can optimize the serving runtime environment, so TensorFlow serving. So this was touched on this morning as well. One thing I see quite a bit on like Stack Overflow and some of these public things is people, yes, everyone has problems with like TensorFlow serving at scale. I'm going to show you guys a problem at scale through the demo because we're just going to slam it. And people just say, just add more behind a load balancer, add a health check, and if it fails, pull it out of the load balancer and it'll get swapped out. So I can actually make it fail within just a minute, right? So there's some like bugs in it currently, but it's fun to do. So here, and then like the other one is this concept of like the batching of requests. That first talk, Riley mentioned this, of course. These are some of the parameters. This is what I have set up right now. This would be, so what we're doing here, just to kind of show you from a math standpoint, why this works, this whole request batching thing works, and this is particularly important for GPUs. So let's say we want to, let's say two different requests come in from like two different mobile devices across the world. It's not the same people. And this is a particular calculation that has to happen for like whatever reason. This is what this particular model requires. So both of these can get collapsed. If we can wait, and I believe the parameter is batch timeout like microseconds, so this is actually going to wait 10 milliseconds, which is high. We're going to wait that long, and that's for like demo purposes. It can actually batch up all of these requests from completely different people. Put them into one big matrix, pass this to the GPU, pass it wherever it has to pass, do one big calculation. When it pulls it back, it knows the offsets. It just zero fills in the rest here, and then can then provide the answers back to each separate client. So this is pretty cool stuff. Let's see. The like obvious trade-off, if you have low scale, you don't want to wait 10 milliseconds, right? You just want to, as things come in, just calculate each of these and then send back the answer. But when you start to load it up, you want to specify, right, and start batching. What you're doing is trading off higher latency for higher throughput, right? Let's see, some of these I stole, the hash ID, that's from the morning stuff. All right, should we do demos? Yeah, okay, train and deploy a TensorFlow model. This is a simple model. This is going to be the immutable. So this is what's actually going to trigger the Airflow workflow through GitHub. I've got everything, again, we haven't left the notebook here. Let's see, boom. Very short training time. There's this nice little show graph helper function. You guys can snag it. I've snagged it from many other people. That's what the graph looks like. What's cool about this nice little JavaScript function is that you can actually go back and start to apply these post-training optimizations, these graph simplification things, and just kind of keep an eye on how the graph is shown, because we could probably see some of the training specific ones here if we look close enough, things that we would want to remove. All right, so we just trained, I think, what version was that? Version 19. Let's just do a quick. So 19 looks like it needs to be added. We're going to add that. I'm kind of cheating in that I'm running GitHub commands and Kubernetes commands from the notebook, but and git push doesn't work, so or from the notebook for some reasons here. What's going on there? Refresh that. And do status. Git push. Actually, it's already been added from the notebook. All right. So let's go back to the notebook. That actually pushed it. We should be able to view. This thing should have kicked off right there. So here we're actually running. So this kicked off. So I've got Airflow. I'm cheating also. I'm like rendering HTML within a notebook here, which is my favorite thing in the world. So this is Airflow. There's a GitHub webhook sitting out there, web service, and it's starting this. So this is going to run for a little bit. What we're going to do is build the Docker image with that new model 19. It's going to push it out to Docker Hub. It's then going to notify. It's going to use Kubernetes, like beneath the covers, to tell it to flip the version that it's currently being used and now use this newer version. So I'll spare you some of the details. Let's go. So while that's running, so the downside of this immutable model, and this is something that like the OpenAI guys have talked about because they prefer this whole like immutable stuff as well, is that you still need to get up and have a cup of coffee and go to the bathroom and get your dry cleaning or whatever, and then come back and get. So what we're going to do now is I'm going to show you guys a version of the sort of scary mutable. But yeah, just to give you guys a view of both here. All right, so let me show you a quick view of the cluster. So I've got actually 4 clusters. So across both Amazon and Google, I have both a training and a prediction cluster. So just real quick, here is Spark on the training AWS cluster right there. And I'm going to do something kind of fun that's just like gratuitous, but I think it's kind of cool. So right now we've got Spark. We've got one Spark worker. This is the actual Spark cluster that we're going to use. And let's run a Kubernetes command that's going to increase the number of workers to 2. So with just one command, I can very quickly, I should just be able to hit refresh here. Boom. Let's hit refresh one more time. Boom. 2. Yeah, so now I've doubled my Spark cluster. I can also look at the specific pods. Think of pods as like an atomic unit. You can combine 2 Docker containers into the same pod, and they can share system resources. They can share disk. They can, but for the most part, I've got a single Docker container per pod. And then there's this thing called replication controller, which is what I'm actually telling this thing to do. That's what the RC stands for here. So I told the Spark workers replication controller to scale up to 2. I can tell it to go to 4 to 10 to whatever. At some point, I'm going to exceed the number of physical resources on these EC2 instances, and that's where auto scaling comes in, and yeah, some of that good stuff. But for right now, yeah, we can handle this. So we should see 2 workers. So here I'm saying get me all the pods, and now we have 2 workers. So that's the command line version. If we go here, yeah, look at that. So this tool weave scope now shows that we have 2 workers. That's kind of cool. And what's even cooler is I can actually scale up and down right from weave scope. So I could do up and down there. I can also, if I'm lazy and I don't want to go command line, I can actually hop on. This hasn't been working recently, so let me see if it works. I can actually hop on to this specific Docker container, right? So again, I've got, this would be the Spark worker. And I don't know if I think it's a problem because I'm running it within the notebook, but yeah, usually that works. I could also click this to look at the logs. I could stop it. I could pause it. I could restart it. I could do some pretty dangerous stuff from this particular cell. So stay away from that. All right, so let's actually build a model. That's probably not the best message title for this. Let's build the Spark model. We're using Spark 201. We're going to load. I've got this fun little S3 bucket. It's kind of like domain name grabbing, with these global S3 buckets. So I snagged Datapalooza, which was, I think, the title of an old IBM conference, which we then found out is actually trademarked by not the U.S. government, because they're not allowed to do that, but some partner of the U.S. government. And so I snagged it before anyone else. Yeah, I like, so riding the legal lines, I guess. So what's happening here is I'm pulling in the Airbnb data set. So the goal here is to predict the price for the particular specs, right? You know, if I have a 2-bedroom and I'm going to be there at the same time, but I've been marked a superhost by Airbnb, which is some glorious thing that people strive for. Yeah, all these features. So I've got continuous features, categorical features, and I'm trying to predict the price that I could get for this sweet San Francisco home. Let's just run through these. These will finish pretty quickly. Let's get going. Splitting, training set, data set, blah, 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 standard scalar. You guys have seen all this before. Here's the linear regression where we're combining the categorical and continuous features. We're using pipelines. So this particular JPMML library supports full Spark ML pipelines. This is huge, right? It didn't used to do this. It was just like individual, one-off, but supports all the full Monty here. So do we get this thing going here? Print that. And then once this is built, this is actually going to generate the PMML, with this JPMML library for the full pipeline, right? Again, so this is all of the feature transformers. This is everything going in. So there's the PMML and all of its XML glory, totally bloated. Now so check this out. This is a live running server. This is one of the servers running in the prediction cluster, which I could show with Kubernetes, but just believe me. So here, pushing out, so I'm actually taking the PMML, the bytes, and I'm actually calling this web service that says update PMML. Here's the name that someone is going to call at some point to do the prediction, but use this PMML when they call it. So this is the latest version. So this is mutable. Call that, I get a 200. Let's see, so here I'm actually going to do the evaluation side of it. I'm giving it the same name. I'm passing in all the good stuff is host is superhost. This person's not a superhost. They should be ashamed of themselves. And what do we get? Here's the price. Doing it on the Google side. Excuse me. Here's the price. It should be the same, I hope. Yep. All right, so let's take a quick look at, I have the Airflow stuff here on this one, a little faster.
So this is deployed two models, one for AWS and one for
Yeah.
Google Cloud.
Yeah. So this finished. So this successfully deployed the new Tensorflow model out to the live running servers. That's using, that's from GitHub, and it's a completely separate Docker image. It can be traced back to any problems that happen in the future. This is really cool. So I mentioned code generation from PMML. I'm not doing that here, but think of, and I guess the new term for this would be like serverless, like a serverless ML model, right? Like a Lambda kind of thing, except it's totally ghetto and not secure at all. So here, I'm actually physically passing in a string of Java code, right? Familiar Java code using map, all that kind of good stuff. This is just a little bonus for you guys. All I'm doing, this very simple model, it's just comparing whatever gets passed in. If it's equal, it's going to return true. If it's not equal to this hard-coded value, it's going to return false. So when I update it, this is, right, like again, this is the mutable model, or this is the mutable like deployment model. I'm pushing it out. On the server, this is its response. It's actually generating, it's using this library that Spark uses actually for its logical plan to physical plan and for the whole stage code generation, like some of the like a lot of the optimizations now that happen within Spark. It's using like the exact same version of the library as well. It's taking a string and it's generating this. Inside of the JVM, it's creating a first class, like Java class that runs this code. And now I'm going to do that. Let's see, Google side. Now, this is the evaluation side. So I believe it was 21619, right? So this I'm passing in, is 21618 the same as 21619? False. Is 21619 the same as 21619? True. One other thing, I actually had this use case pop up. I was in Spain just like a month or two ago. This company actually was describing this. They had a legacy server sitting on like the inside of their firewall that had been serving up like predictions, recommendations, some sort of like classification, whatever. They wanted to get access to it, but they didn't want to expose it, right? Like they wanted to just kind of wrap it, right? So part of it would be served up, but they can probably combine it with other stuff. So here I'm just hard coding. I have a server that does predictions that's just sitting out there. So this is actually making an HTTP client call, right, from my Lambda, from my serverless thing, out to this other server, and then bringing back that prediction.
Chris, you want to switch over to questions?
Is it time to wrap up? Yeah. Is it like, all right. Do you guys got questions? So, yeah, there it is. Yep.
Yeah, with the immutable deploy, what do you actually connect? Is it developer?
It's literally, it's in the notebook here. It's literally so yeah, I used that same exporter thing that the first guy talked about from like TF-Learn, and it like exports the checkpoint file and the graph, the static graph. Yeah. So I didn't do the optimization part of it or anything, but that's kind of the thinking is at some point you would like deploy just like whatever you have to the service, and then it will do all the optimizations, right? That's kind of the value add that the Google Cloud ML people have been talking about. That's how they plan to make money, is these optimizations that they're not rather open sourcing. So yeah. Yeah.
One question.
Sorry, what's that? Yeah. That was the very first. If you go to this repo, yeah, you'll see it. Yep.
All right, thank you, Chris.
Sure.
All right, and then final speaker is Aridit from UC Santa Cruz, previously Apple. He's going to talk about differential privacy. I think this is an important topic, actually. I was just in Europe. Everyone was talking about the GDPR, the new privacy regulation that's coming out in 2018. Basically, if you ignore the privacy measures, you could be fined for like 20 million euros or 2% of your revenue.